Okay, hi guys. So in this video lecture, we'll be continuing with alkyl halides. So in the last lecture, I gave you some basic knowledge on about various types of means reagents, solvents, uh, and the last I gave you one reaction as well. So in this, we'll be looking deep into the alkyl halides, the type of nucleophilic substitution reactions that can um, happen on alkyl halide as a substrate. So let us start off with alkyl halides. Okay, so alkyl halides can actually can undergo nucleophilic substitutions, and secondly it can undergo elimination reaction. Okay, elimination reaction. Okay, so we'll talk about first, that is nucleophilic substitutions. So nucleophilic substitutions is the removal of halide group by a nucleophile or a reagent that is a nucleophilic in nature on alkyl halide as substrate. So we'll talk about SN2 reactions, SN1 reactions, SNI reactions. We'll talk about SN-NGP reactions. We'll talk about SN-AE reactions. We'll talk about SN-EA reactions. Okay, so let's first delve into SN2 reactions. So SN2 reactions are basically substitution of nucleophile in which this happens with a bimolecular transition state. So substitution, just writing the tags here. Substitution happens, it's a nucleophilic substitution, and thirdly it's bimolecular. Okay, so if you see something like OH minus attacking on C, H, C with a partial positive, I with a partial negative, D and T, so you would get something like this as your transition state, wherein negative charge here, H, D, T, and iodine leaving, delta negative. This is the transition state. Okay, this is the transition state or the reaction I have shown in brief. Okay, so the inversion, okay, so after the product form after this is we have OH, H is inverted, D is inverted, and T is inverted. So initially the product was something like this. Now the product is like this, mainly because of the inversion. Okay, so what would happen is OH will attack on one side, and from the other side I minus will leave. Okay, so this is a Walder inversion. Okay, so let's talk about the characteristics of this reaction. First is the rate of this reaction actually depends on the concentration of OH minus and the concentration of Ri. Second point is the rate, the order or molecularity of this reaction is 2. We'll talk about the order and molecularity of a reaction in the upcoming lectures, or you can find it easily in my physical chemistry lectures. Okay, and third is the rearrangement is not possible. Rearrangement is not possible because it's a one-step reaction. Because it's a one step reaction. Okay, so rate actually depends on the nucleophile. This is the nucleophile and this is the halide. Okay, so cis nucleophile attack will attack backside to the leaving group, therefore the inversion of configuration takes place. And actually leaving group would actually also determine leaving group will affect the rate of SN2, as in means if there is a RI, the effect of the rate of SN2 would be more in then RBR, then RCL, and then RF. Okay, why? I have explained you I think twice in previous video lectures also that the rate of stability is I minus greater than BR minus greater than CL minus greater than F minus. Why? Because the size of I minus is greater than the size of the anions are in the decreasing order, hence minus charge would be more stable on a larger atomic size. Okay, so one more thing here is, if you look into this, that CH3 CH2 Cl and lastly when we go down the group, the steric hindrance actually increases, hence rate of SN2 decreases, because as the steric hindrance increases, the coming OH group will find less space to attack the carbon atom from backside. So in this case steric hindrance is the most, hence rate of SN2 decreases. Okay, so with this we end our lecture. From the next lecture we'll be seeing some of the examples of SN2 reactions, and till then good luck and goodbye.